So we had a customer ask us how to do a DXF import with Fusion 360. Let me take you guys into Fusion 360 and show you how that's done. Alright, here I am with a new design. I'm starting blank. You should have an insert option. Then you'll go to insert DXF. You need to select a plane that you'll put the sketch on. See, I rotate my cube around. I have 3 different planes to choose from. For simplicity, I like to choose the plane where the Z-axis points up. That'll help me a little bit later when I move into my CAM settings. Alright, I've selected that plane. Now I'm going to click the folder to select the DXF file. Here I have a sign that I designed quite a while back using Inkscape. I saved it as a DXF file from Inkscape, and now I'll import it here. You should know that you can also import an SVG file. So if you just start with an SVG file, you can work directly with that in Fusion. I'll click Open, and Fusion will bring it in. You notice, depending on how it was designed, it may not come into your workspace the way you'd like in terms of where it is in respect to the origin. But we can deal with that in CAM. I'm just going to click OK here. Now, the first thing that I want you guys to realize is that not every DXF file, or actually very few DXF or SVG files, are going to come in the size that you want to make them. So we need to take a couple of measurements here, see how large it actually is, and get it where we want it. So here's a formula that's going to help you understand how to scale the sketch that you've imported, that sketch being that DXF file that we just imported. Here's how you're going to scale it. You're going to decide what your desired length is for a given dimension, and then what the actual size is in the imported file, and that's going to give you a scale factor. So let's say that I want across this sign, I want from here to here to be 400 millimeters. That's about 16 inches, and that'll be good for the MillRight CNC Carve King. Now I'm just going to measure it. If you didn't see what I did there, I just went to the Inspect tool, and I'm going to click these extreme points here to here. I got 1428.751. Now, I doubt that I originally designed it to be 1428.751 millimeters from there to there, but a lot of times when you're moving from one program to another, things get a little distorted in your files. So I'm going to take that measurement, 1428.751. I'm just going to type it there, okay? My desired size is 400 millimeters. So I want that size, or that length, to actually be 400 millimeters from here to here. And I measured 1428.751 using my Inspect tool, measuring from point to point. What I'll do now is I'm just going to divide 400, which is my desired size, divided by my actual size of 1428.8 roughly. I'm going to get a scale factor of 0.28. So here's what I'll do with that scale factor. I'm going to go to Modify, and I'll select the drop down here, Scale. The entity that I need to select is this sketch. The scale factor needs to be 0.28. And you see it's scaling it here and showing you how large it's going to be relative to the model that you started with. Now I'm going to click OK. Alright, and it's going to give me some warning here that it failed to compute. I doubt it. I think Fusion's just freaking out a little bit. It seems like it computed properly. Okay, so we'll zoom in here. Let's say I want to make something out of this file now. Alright, here I have a family sign, and what I've done with this before is I've pocketed these letters down so it's recessed into the stock, and it makes for a nice look. So let's say I'm starting with some 13 millimeter MDF. I'm going to left click on this face. I'll right click then and tell it to extrude. I'll extrude it to 13 millimeters. Now you don't have to do this here, but I'm going to do it because I think it'll be easier when we move into our CAM settings where we set up our toolpath. I'm going to click each one of these features, and I'm just holding the control button as I click to make sure I select all of them at the same time. Let's say I want to pocket this down 3 millimeters into the stock. So let's think about this a little bit. I just extruded this to 13 millimeters. So this face here that I'm highlighting now with my mouse is 13 millimeters high. Okay, if I'm starting from the same plane, I need to extrude this up 10 millimeters if I want them to be 3 millimeters recessed from this face. Don't let that confuse you. Just 13 minus 10 is 3, and you'll see what I mean when I do it. I'm going to right click and extrude. I'm going to extrude to a distance of 10 millimeters. Okay. Now, one thing that I should not have done there was let it say new body. I'm just going to show you that again. Repeat extrude. I should have told it to join, but it looks like Fusion 360 took care of me anyway. Sometimes if you don't specify that you want it to join to this existing body, then it's going to create several new bodies in your tree here. So you'd have body 1, body 2, body 3. But Fusion 360 took care of me. It knew what I wanted to do here. Alright, so I'm going to go ahead and turn my sketches off, and you can rotate that around and you see what I'm talking about here. If I take my inspect tool and I measure from here to here, the distance is 3 millimeters, which is what I wanted. So now let's move over to the CAM side now that I've got the model the way I want it. You'll notice before I go to the CAM side, I like to turn sketches off. Even though the bulb was still on for the sketch, I've turned all sketches off by this bulb being unlit. I'm going to click on CAM, and I'll do a setup. Every CAM operation starts with a setup. Okay? If you remember from our other video, you need to go to stock and tell it that you do not want to add any additional stock. Sometimes you do, in this case we don't. Okay, I'll go back to setup, and it's trying to set the origin in the middle of the part. That works for me in most cases. This time I actually want to put it here because when I go out to the Carve King and I set this up, I know that I've got only so far of X travel to deal with. If I just start over there close to the left side, close to the negative X direction, and give enough room for my tool path, for my outside contour, I know that I'm safe when it just travels 400 millimeters here. That way I don't have to do a lot of figuring to make sure I'm going to be within my work envelope. This won't always be the case, so you need to be strategic when you set these orientation points. This works for me for this model, so I'm going to move forward by clicking OK. Alright, the first operation I'd like to do here is a pocket operation. Alright, I'm going to go to 2D pocket. The tool that I want for this is going to be a 1/8 inch end mill and 3.175 millimeter is 1/8 inch. I'll select that. This is something I set up previously just so I could have a 2 flute. Now the flute count will impact your feed per tooth. This will automatically calculate based on the number of flutes in your tool and the feed rate and spindle speed. I'm going to turn coolant off because there's no need for it and the machine's not even equipped with a coolant system. If you left it on, it would be okay. It would just kind of clutter the code with extra M codes. I'll disable that. If you remember from a previous video, our spindle speed does not matter if you're running one of the MillRight machines. It doesn't matter because most likely you have not set it up for automated spindle control or spindle speed control. You're manually turning a knob or setting the speed on your router. Where it does matter is calculating your chip load, which is what Fusion 360 calls feed per tooth. You can find different chip load charts on the internet for the material that you're working with and the different tools that you're using. So the recommended chip load for, say, a 1/2 inch cutter is going to be vastly different than the recommended chip load for a 1/8 inch cutter. You also might want to consider derating some of the chip loads that are recommended. They're often intended for industrial machines that can handle large cutting forces that a hobby level machine like the MillRight or many of our competitors won't be able to handle. So I'm going to be using the DeWalt DWP611, and I think I want to run this at about 24,000 RPM. I'm going to have a cutting feed rate of about, let's say 1500 millimeters per minute. That's going to give me a chip load that I'm pretty satisfied with. I'll lead in, because it's a soft material, I'm going to lead in very close to my cutting feed rate. I'm also going to ramp at about the same speed that I lead in and lead out with. My plunge rate, I'll just set to 300 millimeters per minute. Now I need to select the geometry. And I'm just going to go in here because these are the areas that I want to machine. I want to show you something here. Fusion sometimes does something kind of odd. I'm going to close these selections. Notice when I select this one, it just seems to highlight within the feature. That's okay. This one here, it wants to blow it out. In most cases, it's going to machine fine anyway, but just be careful how it generates the toolpath when you see this happen. So I'm just going to go on and select the bottom of each pocket. Okay, the heights I encourage you to leave alone until you understand all of the different options. It's kind of complicated in that you're setting these heights relative to different points in the model. So Fusion 360 will most likely take care of you if you just leave it as a default. Your passes is important. Notice that it wants to leave stock. That would be if you were coming on with another operation and you wanted to perform say a finishing cleanup on the inner contour here. I'm going to turn that off. By default, Fusion 360 wants to machine all the way to the bottom depth of the feature that you've designated to machine. I'm only doing 3 millimeters deep here with an 1/8 inch end mill, so I'm just going to let it do that. In most cases, however, I'd set the multiple depths and then decide how far it can go with each step down. I'm not going to do that in this case on these particular features. I'll move on to my linking tab. Here it's going to, by default, helix into the stock. Now this is only with a pocket operation and some other operations in Fusion. If we were doing a contour operation, by default it's just going to plunge into the stock, which is not ideal for an end mill. I'm just going to accept the default settings for the ramp and click OK. It's going to take a little while to calculate the pocket operation because it's a little more complex. So we'll just be patient and we'll see how it comes out. I'm going to look through. Remember how it made that big blue circle? That seems to be a glitch, but it looks to be machining properly. One thing you want to watch out for on small features is that the cutter is going to actually be able to get in there and machine it. I intentionally chose a small end mill, the 1/8 end mill, to make sure that it got into all the features. As I look through, I'm pretty satisfied with that toolpath. If I'd like, I could simulate that, but I'll do that later. Let's move along now to a contour operation so we can cut this out. I'm actually going to choose, instead of the 1/8 inch end mill, on this one I'm going to do a 1/4 inch end mill. You don't always need to change to a different tool. What's going to drive that is the chip load that you desire. So that's also going to be determined by how fast you want to feed, what your spindle speed is, and what your machine can handle. I'm going to go with the 6.35 millimeter, also 1/4 inch, that I've set up before. And I'm going to machine this contour. So what I'm doing is I'm going to let this 1/4 inch end mill run around and cut this out. Okay. I'm going to change the settings that I have set up for this tool. We'll go to 2000. We'll leave this at 24,000 that we had for the other operation. We'll lead in at 18. We'll lead in at 18, or lead out at 18. We'll ramp at 1800 and we'll plunge at 300. For the Carve King, this is a pretty conservative setting. I'm going to leave tabs on this particular one because I don't want it to move as I'm machining it. By default, Fusion 360 has put far more tabs than I need to hold this in place. So I'm going to make some adjustments here so I don't have quite so much work to do once it finishes. I'm going to change the tab distance to 150. We'll take a look at what that does now. I have a tab here and a tab here. Looks like I've got another tab there, and that should be sufficient for holding the piece down as it's cut out. Again, the heights tab we're going to leave alone. Fusion 360 does a good job of designating those for us based on the contour that we've selected. In the passes tab, we definitely want to make sure we select multiple depths. We don't want to machine all the way down in this 13mm piece of MDF. The Carve King's not going to do it, nor are any of the competing machines going to machine all the way down 13mm at one time. Let's go ahead and make that 4mm. That should be a good setting for the Carve King and still pretty conservative. I want to use even step downs, and what that's going to do, I've designated 4mm here, so it's going to go 4mm deep, 8mm deep, 12mm deep, then would have one more pass to go if I did not select use even step downs. The point is that with a 4mm maximum step down in a 13mm model, it's going to have to make at least 4 step downs. What the use even step downs is going to do is say, well, let me just divide the step down distance by 4. We'll click OK and see what we get. As you can see, it's used even step downs. If I didn't do that, then it would come 4 deep, another 4 deep, another 4 deep, and it would have just this 1mm left. Sometimes that's useful, sometimes it's not. As I look over my toolpath, I realize that I've forgotten to do something that I normally do. Here we see the tool leading into the stock, which is desirable because that will minimize the artifacts of the cutter left on the finished piece. If you don't do that, a lot of times you'll actually see an end mill mark, say right here where it comes in. You're not going to necessarily get all the way away from that, but the lead ins and lead outs will help. What I'm talking about, though, is I did not set up any kind of ramping entry into the stock. It's trying to plunge directly down to each depth. As I said before, that's not ideal for an end mill. I'm going to right click, tell it to edit. I'll go to linking, and I'm going to click for it to ramp. We'll just accept the default ramping settings for now. We could definitely ramp more aggressively, but we won't get into that for now. Click OK, and you see here how it's now ramping into the stock versus plunging directly. All right, now we can look at our toolpaths together and make sure that we've machined everything we want to. I think that looks pretty good. Let's simulate it just to be sure. You'll notice that when you're trying to view the simulation, you've got this big tool holder in the way. It's not actually going to be on the machine, so we can just change it just to flute, and we'll see just the cutting flute doing the work there. If you'd like to see the stock removed as it simulates, you can click stock, and you'll see what it's actually going to cut out. Now, this is a good way of seeing where your cutter won't actually get into and what stock may be left over that you don't expect to be left. We'll fast forward all the way through this so we can see to the end of the simulation. Okay, looking through it, I'm pretty happy with the simulation, so we'll move forward. Now, if you remember, the pocket operation, we're using a 1/8 inch end mill, and the contour operation, we switched over to a 1/4 inch. I do not want to try and run those at the same time. If I do that at the same time, it could just move on to the next operation if there's no pause command placed into the G-code file. So I'm going to actually post-process these separately. I'll run the pocket operation with a 1/8 inch end mill. That operation will finish. Then I'll change my tool out to a 1/4 inch end mill, and I'll run the contour operation. So I'm going to select just the pocket op. I'll go to Actions and then Post-Process. You need to make sure that you are on Gerbil.cps. We've got other machines that run Mach 3, so we need to move back to Gerbil. If you don't do that, you may end up with some odd behavior or some skipped commands. I like to turn G28 off. I won't get into why, but just take my word for it for now. I like to leave Open NC and Editor checked so I can make an edit to the G code. I'm going to name this something relevant. Call it Family Pocket. Now I'm going to click Post. I'll just save it in the file or in the folder that opens by default. You want to make sure you put it somewhere that you can find it though. Click Save. When I click Save, my editor is going to come up. It's a program called Brackets. If you've never done this before, then Fusion 360 is going to try and download Brackets. I want to get rid of G54. This is a work coordinate selection command. I like to leave this out of my G code because I'm not always in the G54 system. Maybe I'm trying to make 50 of these signs and I've set up a clamping jig and I've specified the origin as the origin of the G55 system. If I run this, it's going to try and switch coordinate systems over to G54. Now, Fusion 360 allows you in your CAM setup to change the coordinate system. You could change that to G55 or G56 or whatever you'd like. I like to avoid the issue altogether and select my coordinate system when I'm actually setting my machine up to run the file. So I'm going to delete that and I'll change it to G0Z10. Now what this is going to do is make sure that my cutter is lifted up above the stock before I actually begin traversing in the XY plane. If I wasn't paying attention to what I did, and let's say I just zeroed my cutter to the stock and then tried to run this, it might skim that cutter all the way across the stock and potentially ruin my piece if anything was not perfectly level. So I'm going to get rid of the G54. I'm just going to put a Z-lift and I'm going to go to File, Save. We can move now to our next operation. I'm going to select Contour and I'll go to Post-Process again. Here I'm going to say Family, Sign, Contour. I want to make sure that G28 is still off and I'm opening NC File and Editor. I'll save that. And I'm going to do the same thing here. I'm going to get rid of my G54, change it to G0Z10. I'll save the file. Now that's a wrap on how to import a DXF file, turn it into a 3D model, then set up CAM and generate G code. If you've got any questions, let me know. I'll see how I can help. Thanks.